Math people, here we've got our next ratios lesson. Let's get to it. Set up your notes. Remember, you're taking some brief notes on this. Nothing crazy. You're not writing down every single word. Just do your best to capture the main ideas. So this is chapter 3, lesson 4. And in ratios world, today we are going to be graphing ratio relationships. Here we go. Before we get into the actual graphing of ratios, let's do a little bit of a recap of just graphing in general. So what I've got before you here is a coordinate plane. A coordinate plane is where we plot or graph points. So for example, here's a point. Here's a point. Couple things to remember. Number one, there are two axes on a coordinate plane. We've got the x-axis, that is the one that runs horizontally from left to right, and we have the y-axis, that is the axis that runs vertically up and down. Another important spot on a coordinate plane to remember is this location that I'm circling, bottom left corner. This is known as the origin. The origin is where you will always start when you go to plot a point. This represents the spot 0, 0 on a coordinate plane. So the origin, its location is 0, 0. And with that being said, 0, 0, this thing I wrote here, that is a coordinate pair. That is telling me where I'm going to go on the graph. So an ordered pair, the first number represents the x and the second number represents the y. So the first number in the ordered pair tells you how far to go left or right, and the second number tells you how far to move up or down. Now in our case, we're only going to be moving to the right and up. We're not moving to the left or down. That'll be at a later lesson this year. Let's practice plotting 2 points and then we'll get going into our ratios part of this lesson. So if I had the ordered pair 2, 3, that tells me that I'm going to move 2 to the right, that's the x value, and 3 up. I'm going to slowly plot this point just to make sure we're okay with plotting points. You always start at the origin. Think of the word originate where you begin. We're going to begin at 0, 0, and we're first going to move to the to the right 2 spots. 1, 2. So I'm here, you can see where my mouse is. And then the second number, the y value, tells me to move up 1, 2, 3. And I end right here at 2, 3. I think of an ordered pair as like GPS directions. It's telling you where to go. Move over 2, up 3. Let's do one more point. I'll use green for this one. Let's go to the point 5, 5. So the first number tells me to move to the right 5 spaces. So start at the origin, where I originate, where I begin. 1, 2, 3, 4, 5. So I'm here. And then the second number tells me to move up 5 spaces. The y tells you how far to move on the y-axis. Up 1, 2, 3, 4, 5. And I end up at this spot right here. This is the point 5, 5. So there's a quick little refresher on graphing points in the coordinate plane and some important features of the coordinate plane: an x-axis, a y-axis, and the origin. Now, if you remember how to plot points, graphing ratios is quite simple. And the way that I'm going to do this is I'm going to go through 4 example problems. And in each one, I'll point out a couple things about graphing ratios. So just pay attention to each of the examples. I recognize that at home you probably do not have graph paper. That's okay. Do your best if you're trying to recreate a graph or two in your notes. It doesn't need to be perfect. In class, I will provide you with graphs. When you're at home on your own, Just do your best to try to make something that's somewhat straight and somewhat resembles a graph. It does not need to be perfect. Don't go nuts. Here's example 1. The directions say represent the ratio relationship using a graph. All right, we can do this. First off, I look at this ratio table and I see that it's a relationship between cups of flour and cups of water. Before I can do anything here, I need to recognize that ratios can be put into ordered pairs. Ordered pairs meaning, let's go to this first point here. Cups of flour, cups of water, we could represent that as 4, 2. That could be the ordered pair that represents the 4:2 ratio. This other point, 8, 4, 8 cups of flour, 4 cups of water, 8, 4. And this last point here, 12, 6, 12, 6. So now I've got 1, 2, 3, 3 ordered pairs that I can plot on this coordinate plane. The first number in each of these points, so that would be the 4, the 8, and the 12. Those all represent flour, cups of flour. And the first value in an ordered pair is the x value. So on my x-axis, I'm going to label this as cups of flour. The second value in each of these points, the 6, the 4, and the 2, 6, 4, 2, those all represent cups of water, and since they're the second number, those are going to be the y value in my ordered pair. I'm going to label my y-axis as cups of water. So one important thing to remember is make sure you label each axis. Then you also need to make sure that after you've labeled each axis, you need to create a scale for each axis. So when I say scale, I mean, what are you going to count by? What is each line going to represent? Is each line going to be 1? So this would be 1, 2, 3, 4, 5, 6, etc. Or is there a better scale that will fit your numbers a little nicer? Now this is the one thing that takes a little bit of brain power, not much. Look at the numbers that you have and think, what could I count by that would make these numbers fit nicely on my x-axis? 4, 8, and 12. Well, you could go really simple and just make each of these a 4. So you could do 4, 8, 12, 16, 20, etc. And you know that your numbers are going to fit exactly on a line here. Alternatively, you could say, I'd like to spread it out a little bit more. So I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. And that could be your scale. You could count by 2s. If you really wanted to, you could count by 1s, but it would take a while to get all of the numbers that you need. And we're only using every 4th number, so counting by 1s does not seem like a great idea, but you could do it if you wanted to. I'm going to leave it as counted by 2s. You could count by 4s, whatever you prefer. Same thing on the y-axis. What am I going to count by? What's my scale going to be? I'm going to count by 2s, since all the numbers are going by 2s anyways. That seems like a reasonable thing to do. So I'm going to go 2, 4, 6. So you see each line, I'm going up by 2. All right. So number 1, I've labeled my axes, cups of flour, cups of water. Number 2, I have scaled each axis, counting by 2s on each. You could have counted by 2s on this one and 4s on this one, or 1s on both. It doesn't really matter, just so that you're consistent in how you're counting. And now I'm going to plot each point. So the first point I'm going to plot is this one, 4, 2. Go to the origin. First number tells me to move over 4, so over to 4. And the second number tells me to move up to 2. And that's my first point. This would be 4, 2. This point represents 4 cups of flour to 2 cups of water. Next point, 8, 4. So I'm going to move over to 8 on the x and up to 4 on the y. 8, 4. And then the last point I'm plotting is 12, 6. So that tells me to Move over to 12 on the x, and up to 6 on the y. 12, 6. Now, you'll notice that these points, if you were to connect them with a line, which I'm going to do right now, what do you notice about the line? I notice that the line is perfectly straight going through those points. There's not a point that's like up here and down here and over there. These points are perfectly straight. And the reason for that, this is an important thing to note, because ratios in a ratio table are all equivalent to one another, the line that forms these points when you graph them should be a straight line. Straight line signifies that everything is equivalent. Everything is moving over and up by the same amount because everything's equivalent. So if you ever plot a ratio on a coordinate plane, you should see a straight line forming from the points. And if you don't, that's a key indicator that you've plotted something incorrectly. Ratios have to form a straight line, and that's an important thing, so I'm going to write that down. Ratios, when graphed, must form a straight line. All right. That's an important thing to remember. And there we go. We've plotted our very first ratio relationship in the coordinate plane. Easy as pie. Let's try another one. So analyze what we have here, and let's come up with some ordered pairs. I'm going to write my ordered pairs as 1, 10, 2, 20, and 3, 30. First question for you is, what is going to be the label of the x-axis? All right, if you came up with time or hours as your label for the x-axis, kudos to you. The reason that's the x-axis is because that's what the first values represent. 1, 2, and 3, those are all x values. Those all represent time in hours. So our x-axis should be time in hours. Second question, what's the y-axis going to represent in this example? If you came up with earnings or dollars for this, you're in good shape. That's what it should represent, because all of the second numbers, 10, 20, and 30, are all the y values. And so the y-axis should be earnings in dollars. At this point, we need to scale each axis. I think that the x-axis, the time, makes perfect sense to just count by ones because it's going up by ones in our table. So 1, 2, 3, 4, 5, etc. Each line on our coordinate plane should represent 1. The scale for the y-axis, on the other hand, I probably wouldn't count by ones because I need to get to the points 10, 20, and 30, and I would have to go really, really high up here if I was counting by ones. So instead, I'm going to count by tens, though maybe you want to spread it out a little bit more. You could count by fives if you really wanted to. If you counted by fives, you would definitely be able to fit 10, 20, and 30 on here. So it's up to you. I just think it's easier to count by 10, so I'm going for what's easiest. But visually, if you wanted your data to be a little more spread out, you could count by fives. There's nothing wrong with that. All right, we've got our scales set, and now we're going to plot our points. First point we're going to plot is 1, 10. So that tells me to go over 1, up 10. Boom, first point, 110. Second point, 220. So I'm going to go over 2, up 20. Next point, and our final point, is 3, 30. So that tells me to go over 3, up 30. And there you have it. You've plotted the ratio relationship in the coordinate plane. I'm going to connect them with a line segment, which we know should be what? Straight. All ratios, when graphed, should form a straight line. And there you have it. There is your ratio relationship of time spent working to the dollars earned. You're earning $10 an hour. So in 2 hours, you earn $20. In 3 hours, you earn $30. We could look at our graph and see that at 4 hours, we're going through the 40. So you earn $40. All right, at the top of the video, I had said we were going to do 4 examples together, but I'm going to cut it and say we're going to stop right now after these two examples. We've seen the basics of graphing ratio relationships. We talked about the basics of a coordinate plane, the x and y axis, the origin, etc. We're going to stop here for now. We'll do a bunch more practice in class. Please bring any questions that you have on the basics that we've covered in this lesson so far, and we'll take it from there in class. See you later, math people.